Hello and welcome to my presentation of the article Access Control for Smart Manufacturing Systems. My name is Björn Leander and I'm an industrial PhD student at Mälardalen University in Västerås, Sweden. I also work as a senior R&D engineer at the ABB in the business area of industrial automation and the division of process control platform. This work is partly sponsored by the Knowledge Foundation through the Automation Region Research Academy. The outline of this presentation would be that I first shortly discuss the background and motivation behind the research and mention something about the research questions and methodology used to reach the results. I will introduce a very simplistic smart manufacturing scenario that is used in the research, and then the results will be presented. Firstly, a list of requirements, and then an assessment of the attribute-based access control model against these requirements. Finally, we will discuss conclusions and future work. Smart manufacturing is an evolving trend within the manufacturing industry. It's being part of the Industry 4.0 paradigm. And from the business side, there's a great pull to go toward this technology as it enables some potentially lucrative business prospects. There are, however, great implications on the technical side. Important aspect for this work is the inclusion of new technologies and stakeholders into the system, and the concept of modularized manufacturing, where manufacturing units has self-contained capabilities to perform its tasks. This, of course, has cybersecurity implications as well. The complexity of the system is increasing with new stakeholders, and dynamic behavior are making current techniques of protection through segmentation and whitelisting less useful. The attack surfaces of the system is also expanding, and attacks can of course have a potentially severe impact both economically for the factory owners and possibly also related to safety, as these are cyber-physical systems. Access control is one of the classical security controls in any software system. In general, we can speak of access control being split into three different categories: identification, authentication, and authorization. Identification and authentication is about establishing and providing proof of the identity of an entity in the system. Authorization is how to deny or grant requested privileges to an entity. And this work is focusing on authorization, more specifically about how to express rules or policies. An access control model is the formal description on primitives available to express access control policies. Even though access control is really an effective mechanism for protecting against a range of cyber attacks, it's relatively undeveloped in the traditional automation and manufacturing systems. The models for policy formulations that are currently in use are furthermore not optimal for the dynamic systems envisioned, for example, smart manufacturing. Attribute-based access control is one of the relatively novel access control models that has been suggested as a better fit in relation to Industry 4.0 systems. In attribute-based access control, privileges are inferred based on logical expressions on the attributes for both the subjects, the resources, and the operating environment. So therefore attributes are a very flexible concept and can be used to describe several aspects of an entity or the environment, such as the current batch ID assigned to a machine, the time of the day, or the working hours of a service engineer. In this work, we want to understand what the requirements actually are on access control model to be useful in a smart manufacturing environment, and make an assessment of attribute-based access control to understand if it is a feasible choice. So two research questions were formulated to guide this research, and the first one is related to requirements on the access control model, and the second one related to the assessment of attribute-based access control in relation to these requirements. And for the first question, we performed a simplistic literature review, and for the second one, a use case study was performed. In the article, we use a simple use case scenario to illustrate some of the implications of using attribute-based access control together with smart manufacturing. The scenario is extremely simplified and a lot of details are clearly left out. The important thing in our context is to discuss the different entity interactions and the rules that govern these interactions. In the scenario, we have a number of devices that is cooperating in order to fulfill a specific production scheme of a product. These devices has to exchange information on product handover. There is a customer outside the organization interested in fetching information on placed orders and purchased products. And we have a service engineer who is responsible for the continuous operation of some of the devices within the manufacturing environment. We argue in the article that the rules for all of these interactions can be expressed based on attributes of the entities. So the result of the small literature review, and as an answer to our first research question, the following requirements were derived. I will not go through all these in detail, but focus only on two. The requirement we call scalable and the requirement we call flexible. For details on the other requirement, please take a look in the article. Scalable. As discussed, the smart manufacturing systems are complex and dynamic systems, and therefore management of policies for a huge amount of devices, services, and users must be feasible and cost effective. Flexibility. As the use of a smart manufacturing plant may not be predefined, the composition of devices and services and users that must interact in order to fulfill a specific manufacturing scheme will shift frequently. So therefore there is a need for high flexibility also in the policy formulation, following if you want to follow the principle of least privilege. So how does the attribute-based access control model match these requirements? Also here I would like to refer the interested listener to the article for details on the other requirements. For scalability, our understanding is that attribute-based access control have no inherent support. The management effort may not scale well with increasing size and complexity of the system. The information we have speaks rather in the contrary direction, but the actual outcome here will be highly dependent on what policies are required and how they can be formulated, also relating to the available attributes in the system. The flexibility requirement is, on the other hand, strongly supported by the attribute-based access control model, as the use of logical arguments based on attributes allows for extremely fine-grained policy expressions. However, also in this case, the availability of attributes will be the deciding factor. So, to conclude the presentation, we can summarize. We have derived a number of basic requirements for an access control model to be used in a smart manufacturing system. We have evaluated the attribute-based access control model in relation to these requirements and illustrated the use of attribute-based access control in a smart manufacturing scenario. And the outcome of the evaluation is that attribute-based access control has some very well-suited characteristics fulfilling part of the requirements, but there are several areas that must be further developed and investigated. And some of these areas where the model itself does not provide the functionality, the enforcement part of the authorization mechanism can possibly provide an answer. This relates, for example, to the requirements on availability and efficiency. And management of policies are clearly one of the major issues in a system with high complexity and dynamic behavior. To minimize the overhead for engineering or security personnel, there may be answers in the area of model-driven security. And we would also like to look at more realistic use case scenarios to increase the understanding on the range of needed attributes, etc. Thank you so much for listening to my presentation, and please contact me on these email addresses or ask any questions directly after the presentation. Thank you.